have looked at different forms of differentiations, chain rule, product rule, quotient rule. Today we are going to look at how we can differentiate implicit functions. First and foremost, what is an implicit function? This is a function which cannot be expressed, which term cannot be expressed in terms of the other. For example, you cannot have x expressed in terms of y, or you cannot make x the subject, either way you cannot make y the subject. Now, like these numbers here, we can look at the first example. First example 1, part A, we want to differentiate x squared plus 2x cubed y minus 3y squared. This is equal to 0. How can you differentiate a number like that? When you try to make any of the subject, it is literally impossible. So you just have to differentiate each term independently. And how do you do that? Differentiating this independently, d dx of x squared. I'm differentiating with respect to x because that's what the question says with respect to x. So I introduce a derivative with respect to x on x squared. Then I also differentiate d dx of 2x cubed y. Then minus, I also introduce another derivative with respect to x of 3y squared. This is equal to 0. Now, when you differentiate x squared, we saw in our previous videos, we drop the power, reduce the power by 1, that is 2x, plus. Now, differentiating this one, it's a product. So product, we saw very well, for you to differentiate a product, it is simply u dv dx plus v dv dx. The previous videos have it. So we have our two constant. We can first leave it outside. So we keep x cubed constant. We differentiate y with respect to x, so that one gives us a dy dx. Then plus, we keep our y constant. Then we differentiate x cubed. Remember the 2 is outside here, so we don't have to bother with it. So keep y constant, differentiate x cubed, it will give us a 3x squared, then minus. Still, we have this power 2. When the power 2 drops, it becomes 2 times 3, which is a 6y. 2 minus 1 is 1. Then, since I'm differentiating y with respect to x, that is why we have it as dy dx. When this is, if you differentiate a 0, it will become a 0. It's a constant. It is going to become a 0. Maybe just to talk about something small, if you differentiate x with respect to x, this is simply a 1, because this and this is a 1. But if you differentiate y with respect to x, that is why we are staying with the dy dx. That's why we have this dy dx, this dy dx, because we are differentiating y with respect to x. So the dy dx has to remain. Now, the following step, you're going to open brackets and we allow it as 2x plus 2x cubed. This is dy dx plus 6y x squared minus 6y dy dx is equal to 0. Then we can collect like terms. I have a dy dx for this and this, so I can have it as 2x cubed. This is dy dx minus 6y dy dx is equal to, now these ones that are not having dy dx, I put them on the other right hand side, so it becomes a negative 6y x squared, then minus 2x. Factorize out the dy dx because it is what we want. So dy dx into 2x cubed minus 6y is equal to negative 6y x squared minus 2x. Then divide through on both sides by this term in the brackets, such that our dy dx narrows down to negative 6x squared y, it is the same, minus 2x. All of this is divided by 2x cubed minus 6y. So this is the answer, which you can also have as dy dx being equal to, the negative is pushed down, it affects this one such that we have 6x squared y plus 2x. The whole of this is divided by, now this becomes a positive 6y, and now this becomes a negative 2x cubed. So this is what we have for this part A. You can feel free to pause and go through the work. Then still in the same line, we are going to look at another example, still example of an implicit part B. Another example goes, they have given us x, y in brackets squared is equal to 3x squared y, then minus y squared x, then plus x. Okay, so still this is an implicit. It is very hard for us to make any subject, so we differentiate each term as it is. Now I can first of all open this bracket, say I have it as x squared, y squared is equal to 3x squared y minus y squared x, then plus x. I think it is plus x. So I'm seeing there is some common term which is x. We can first of all get rid of that x. We have it as xy squared is equal to 3xy minus y squared, then plus 1. This is the same as that. Because I'm seeing x is common, then we can start differentiating each term independently. So we are saying ddx of xy squared is equal to d dx of 3xy minus d dx of y squared, then plus d dx of 1. This is a product rule because you have input values being multiplied. So the principle says you keep the first one constant, then you differentiate the other one. So in differentiate the y squared, we get this is times 2y, but the y dx has to remain in, then plus, now we keep y squared constant, we differentiate x, that's a 1, this is equal to, this is still another product, this is we keep and get out the 3, then keep x constant, differentiate y, you get dy dx, plus you keep y constant, you differentiate this x, is a 1. Remember the 3 is factored out, so it shouldn't bother you so much. This is minus, when I differentiate this, I will get a 2y dy dx, then plus, this is a 0 when I differentiate a constant. Then I can open brackets and try to collect like terms, those that have in dy dx. So I'll have 2xy dy dx. Then I have, when this one crosses equal signs, it becomes a minus 3x dy dx. Then I also have, when this one crosses this equal signs, it becomes a plus 2y dy dx. Then whichever term that is not having a dy dx on it crosses to the right hand side, and the sign is going to change. So here we have minus y squared, then we have a plus 3y, then there is a 0 remaining. So factorize out that dy dx, you will stay with 2xy minus 3x plus 2y. This is equal to 3y minus y squared. Divide through on both sides such that our dy dx is equal to 3y minus y squared. Then the whole of this is divided by this term, which is 2xy plus 2y, then minus 3x. It is the same.